This is Algebra 1, Lesson 32, Word Problems. We're going to be finding the missing number. We're going to do examples 32:1 through 32:5. The sum of twice a number and 13 is 75. Find the number. Now you may remember in a previous video we talked about taking verbal phrases and changing them into algebraic expressions like this. So let's just start with the old part. The sum, so we know we're going to be adding. What are we going to add? We're going to add twice a number. Well, we don't know what that number is, so we're going to call it n. So twice a number would be 2n. The sum of twice a number and, so this is the other thing that we're adding, 13. So let's just check to make sure this matches. The sum of twice a number and 13. We've got a sum, and we've got twice a number, and we've got 13 being added. There's our expression that matches with the underlined part. Now, it's not an expression that they want an equation, because here they say is. So we're going to write equals 75. So now we have an equation that we can solve. Now we're going to find the number. Now we know the steps for solving equations. We've been doing that. We're going to, if we had parentheses, we'd get rid of them. We do not. If we could combine like terms on either side of the equal sign, we would, but we don't have that. So let's go ahead, and we only have one variable on one side. Let's get rid of the constant term that's with the variable. And we're going to get 2n is equal to 62. Now we've got a numerical coefficient of 2 multiplied by the n, so we're going to divide both sides by 2. And we're going to get n is equal to 62 divided by 2 is 31. Now, that is what we think the number is, but we always need to make sure we can check it and make sure it's right. So let's take 31 and put it back in. The sum, so we're going to be adding twice a number. So what is 2 times 31? Well, that's 62. And what are we going to add to it? We're going to add 13 to it. And when we do that, we get 75, and that's what we are supposed to get. So we can see that that works. Example 32:2. Find a number. I'm going to erase what's above here. Find a number, so that's going to be n, such that 13 less than twice the number. 13 less than, I'm going to put the less than together, twice a number. Now, if we're doing 13 less than, that's not 13 minus. That's not what we want. If we say something is 13 less than, like if I said 13 less than 20, I would do 20 minus 13, right? To find out that 7 is 13 less than 20. So the order then is I'm going to be doing 13 less than twice the number. Okay, so 13 less than twice the number is 137. Now we can solve that equation. We're going to add 13 to both sides. And if you're having trouble with solving the equations, you can go back to the steps that we talked about in a previous video. And we get 2n is equal to 150. Now we're multiplying by 2, and you can divide both sides by 2. And we find out that n is equal to 75. Now we can check that. Find a number such that 13 less than twice the number. So let's do 75 times 2, which is 150. But then we're going to do 13 less than that. And we get 137. So we can see that it's right. Let's go to 32:3. Find a number, so we're going to say that's n, such that if 5 times the number, 5 times the number, or, we can just put it right next to it. That means times. such that 5 times the number is, such that if 5 times the number is decreased by 14, the result. What do they mean by the result? Well, they're saying the answer, or that's what it's equal to. The result is, we'll put that all together for the equal to, twice, so we know we're going to be multiplying by 2. What are we multiplying by 2? The opposite of the number. We know how to write the opposite of the number. Okay? Find a number such that if 5 times the number is decreased by 14, the result is twice the opposite of the number. Now, on the right side, we can simplify that a little bit. If you're going to multiply 2 times the opposite of n, that's just the opposite of 2n. Okay? You can think of this as a 1 here, and the 2 times the negative 1 is just negative 2. Makes it a little simpler. Now, we have variables on both sides of the equation, so we could subtract 5n or add 2n. If you add 2n, you're going to end up with a 0 on the right side, which is totally fine. That is okay for us to end up with. But I think it might be easier if we subtract the 5n from both sides. That might be a little bit easier. Oh, you know what I did? I think I put a 2 instead of... No, that's right. Twice the opposite of the number. That's right. All right, so now what we're going to do is I'm going to subtract 5n from both sides. And when I do that, I am going to get negative 14 equals negative 7n. Notice here, this is negative 2n minus 5n, which is a negative 7n. All right, when I do that, I can see I'm multiplying by negative 7 times the n, so I'm going to divide by negative 7. And that's going to simplify there to just n. Negative 14 divided by negative 7 is positive 2. So my number is 2. And we're going to check that. We're going to say, find a number. Here we go. Such that if 5 times the number, so let's do 5 times the number, is decreased by 14, the result is twice the opposite of the number. Okay, so let's do that. That's 10 minus 14. That's negative 4 on that side, and 2 times negative 2 is negative 4 on this side. And so we get negative 4 on both sides, and we can see that it's correct. So we checked it. 32(4). Find a number, so we're going to call that n, which decreased by 18. Decreasing it means you're subtracting from it. Find a number which decreased by 18 equals 5 times its opposite, it being the number, so it's the opposite. So now we can simplify that a little bit. Again, here this is like a negative 1, so this on the right side would be negative 5n. n minus 18 equals negative 5n. Now we've got variables on both sides. So what we need to do is either subtract n from both sides or add 5n to both sides. I think I would rather, well, yeah, let's do that. We'll get a 0 this time. And you can see what that's like. Let's add 5n to both sides. So here, 1n plus 5n's is 6n. I bring down the minus 18, and that equals negative 5n plus 5n cancels out. So you may say, well, that's nothing. Yes, but nothing is a number, right? It's 0. So it's okay to have a 0 on that side. That's totally fine. 0 is a number. So now let's get rid of this constant term that's with the variable. And we're going to get 6n is equal to 18. And then we're going to divide both sides by 6. And we get that n is equal to 3. Now, when we get that number, we want to make sure that we check it. And so we go back up here, find a number, we think it's 3, which when decreased by 18, it equals 5 times its opposite. So what's the opposite of 3? Negative 3. 3 minus 18 is negative 15, and 5 times negative 3 is negative 15. So it works. Last example for this lesson. 32.5. We get the same result. So we know two things are equal to each other. We get the same result, and here's one situation. If we multiply a number by 3, or here's our second situation. If we multiply the number by 5 and then add 2. So the number is going to be n. So the first situation is if we multiply a number by 3. If we multiply a number by 3. So we're going to multiply the number by 3. Second situation. If we multiply the number by 5, now that doesn't make sense, does it? Some number times 3 is equal to the same number times 5, unless the number were 0, right? Except for they don't stop here. They keep going. If we multiply the number by 5 and then add 2, multiply it by 5 and then add 2. So this is our equation. We don't have any parentheses. We do have variables on both sides. I'm going to go ahead and subtract 5n from both sides. You could have subtracted 3n and you would have had a 0, and you could just go with it. 3n minus 5n is negative 2n equals positive 2. Now I can divide by the negative 2, and I get n is equal to negative 1. That's what I think it is, so let's go back in and let's check it. We get the same result if we multiply a number by 3. So we're going to multiply the number that we think it is, which is negative 1, by 3. And we think that's going to be the same as if we multiply that same number, negative 1, by 5, and then add 2. 3 times negative 1 is negative 3. 5 times negative 1 is negative 5. And when we add 2 to it, we get negative 3. So we end up with negative 3 on both sides. Since both sides are equal, then that checks out, and n must be equal to negative 1.